Hi, my name is Jordan Taylor, and I'll be talking about one of my favorite phenomenon, Einstein rings. The basis of this phenomenon is the distortion of light. Our brains operate in a Euclidean world, and so we assume that the photons that reach our eye traveled in a straight path, that we can trace that path back to discover the position of objects. However, when lenses are present, this doesn't exactly hold true. The most common lenses we see in life are glass and water. So, if you're looking into a pool, you'll notice that the world around you seems warped. Lenses can cause objects to look magnified, shifted, or distorted to our eyes. Distortion can also occur in the presence of massive objects. Massive objects are going to bend the space around them, and smaller objects are often going to follow this distorted path of space. So imagine you have a bowling ball and you place it on a trampoline. The trampoline's going to dip. If you then roll a marble past this bowling ball, the marble is going to follow this dip path created by this massive object. In space, this ends up with the phenomenon of gravitational lensing. Gravitational lensing essentially means that gravitational fields of massive objects are distorting the space around them, and that light is going to follow this distorted path of space. And so, this was first theorized by Albert Einstein in his theory of general relativity, in which he describes reality as a flexible, dynamic, dimensional grid. And he says that it will only correlate with our mind's eye Euclidean lattice in the absence of energy, in the absence of mass. However, there are many massive gravitational fields in space, from black holes and from stars and galaxy clusters. And so, what this means is that our perception of position in space is not always reliable. This was most famously verified by Sir Arthur Eddington in 1919 when he went to the island of Principe to catch the solar eclipse. And what he observed is that the position of stars behind the sun were slightly adjusted so that you can now see the stars beyond the rims of the solar eclipse. And so he knew this meant that the light from the stars was being bent by the gravitational field of the sun into the telescope where he would not have seen them otherwise. And so some of the most common phenomenon now are Einstein crosses, arcs, and rings. And so if light from a star is emitted in all directions, we assume we are only going to see the light that is emitted directly towards us. However, in the presence of lenses, it can deflect light into telescopes and into our eye that we would not have otherwise seen. And so in Einstein's cross, this is an image of one quasar that is quadrupled. And so the light from this quasar is fluctuating. And as it fluctuates, it allows us to measure the distance that the light has traveled. And this has allowed us to do many things, including measure Hubble's constant, which is the rate of expansion of the universe. As light passes through the galaxies and the black holes of the universe, it brightens and dims. And this allows us to kind of map regions near black holes in a much smaller magnitude than we would have been able to with the telescopes we have today. Now, one of my favorite aspects of this phenomenon are arcs and rings. And so, arcs and rings occur when the viewer, the lens, and the source of light are aligned. And rings only occur when they are perfectly aligned. And it's essentially this ring in space. And it creates this eye like structure. I think it's truly beautiful. And that's why I chose to present on it today. So, thank you for listening to my presentation.